Hello students, welcome to another lecture of machine tool technology. The subject code of this subject is 502, which comes under the diploma mechanical engineering syllabus. And today we will discuss the topic cutting variables. My name is Professor Ghanshyam Javalkar, and I'll tell you something about the cutting tool variables. I'm a assistant professor in SIIT College Bhopal. So let's start the lecture. Now, what are the cutting variables? While we are doing the machining, the cutting operation can be performed, and this cutting operation uh, depends or affect the life of the tool, the machining time, and some variables which can vary the cutting or machining of the tool or machining of the process. So that's why we have to keep in mind what are the cutting variables which can affect the tool life and the timing of machining and the overall process. So that's why cutting variables are very important from the subject point of view as well as the knowledge point of view. So while we are having a machining operation, supposed to be example of suppose to take the example of lathe machine. So in the lathe machine, while we are making a cut or while we are machining, the workpiece is revolving, and due to the revolution of the workpiece, uh, we have a tool on the tool post, and tool post is supposed to be feeded, and we can get the chips like this. So this is the rotation of the workpiece, and there is a contact of the tool on the workpiece, and there is the turning operation. This is known for us. This is the turning operation. Now we are feeding the tool in the direction, and the direction of the feed of the tool is like this. This is the feed in the I can say that the direction, this is the direction of the feed of the tool. Okay. Now tool is fitted in this direction. Also there is the depth of the cut as well as the chip formation, the type of material, the tool. So these things are the cutting variables. So let's discuss the cutting variables separately. So, as this is the example of a lathe machine, in each and every machining process, either it is milling, boring, drilling, and the number of machining process we have, in each and every machining process, the cutting variables are very important. So, you can see this is the operation in the lathe, the turning operation. We have seen earlier, the previous slide is showing the turning operation of the lathe machine. In the milling, we are also getting the chip formation, and the process is somewhat different from the lathe turning. The drilling is also similar to the milling, but the tool is different. The shaper, brushing machine, grinding. So all the machining process, making the chips, and there is a depth of the cut, there is a speed of the relative speed, or we can say that cutting speeds. So all these things are comes under cutting variable. On these cutting variables, the machining process is classified, or the process can be fast or slow. So these are very important. So you can see another thing. Supposed to be this is let's take the example of a lathe machine. This is the three-jaw chuck. In between the three-jaw chuck, the workpiece is fixed, and there is a rotation of the workpiece with the help of the chuck and spindle, and the tool is fixed, and we are having a turning motion on the lathe machine. So DF and D0, DF and DO are the outer diameter and the finished diameter, or the outer diameter and inside diameter. This is the finished diameter that we require on the workpiece, the shape that we require of the shaft. And this is the workpiece, this is having a rotation. Now this is the D. The difference between DO and DF is D. This is the depth of cut. And we are feeding the tool. This is the green color tool, and this is not green color tool. This is we are denoting this as a green color for differentiating the total setup. Uh, and this is the feed in the direction. So this is the direction of the feed, and this is the chuck. On the chuck there is a rotation. So in the schematic diagram, you can say this is the 3D diagram, and in the schematic diagram, you can see all the things separately. This is the depth of the cut, DO minus DF is the depth of cut, and we are giving the feed to the tool. So these are the cutting variables. So also the relative speed or cutting speed V is the largest. This is the first cutting variable is the largest of relative velocities of cutting tool or workpiece. In turning, it is the speed of the workpiece, while in the drilling and milling, it is the speed of the cutting tool. So this is basically the relative motion between the tool and the workpiece. Somehow we are rotating the workpiece, somehow we are rotating the tool. So in the drilling operation, we are rotating the tool and the workpiece is fixed. But in the case of lathe machine, we are rotating the workpiece and the tool is fixed and feeded. Okay, so cutting speed is the distance traveled by the work surface in unit time with reference to the cutting edges. Cutting speed of a cutting tool can be defined as the rate at which its cutting edge passes over the surface of the workpiece in unit time. It is normally expressed in terms of surface speed, referred to as speed, and expressed in meter per minute. In turning, it is given by the surface speed of the workpiece V is equal to R into omega, where R is the radius and 2 pi n omega can be represented in the revolution term 2 pi n by 60, or this can be also represented at this form, in this form, where D is the diameter in millimeter and n is the rpm, revolution per minute. And v is the linear velocity and omega is the angular velocity in Newton per second. So this is the first variable. While we are having a machining operation, we have to keep in mind. So what is the cutting speed of the machine, and this can vary the things for machining process. The second is fed. The second is feed. The feed is the distance advanced by the tool into or along the workpiece each time the tool point passes a certain position in its travel over the surface. In case of turning, feed is the distance that the tool advances in one revolution of the workpiece. So feed is generally while there is a workpiece and the revolution of the workpiece is supposed to be one. In one revolution of the workpiece, the tool the distance traveled by the tool is called the feet, and this is millimeter per revolution. That's why. Or feet in millimeter per minute also, or feet in millimeter revolution into n can be the second variable of the cutting. Now the third variable of the cutting is depth of cut. It is the distance through which the cutting tool is plunged into the workpiece. Or we have already seen that the difference between DO or outer diameter minus inner diameter, the finished diameter, is the depth of the cut. Thus, it is the distance measured periodically between the machined surface and the unmachined, uncut surface, or the previous machined surface of the workpiece. And the depth of cut D is expressed in millimeter. It can be also in meter, uh, but generally it is taken in millimeter, and it is calculated by D1 minus D2 upon 2 for turning operation, as we have seen in the lathe machine. It's here. So this is the D2, this is D1. So D1 minus D2 is the depth of cut, and this is uh, known for us. So these are the cutting variables. If we keep in mind how they are varying, what is the depth of cut, what is the feed, and what is the speed, we can simplify the cutting operation, and this can be the skill of the machinist. So in this lecture, this is sufficient. We talked about the cutting variables. I hope you understand today's lecture. Thank you.